Okay. All right, so binary acids, non-organic binary acids, we're going to drop the gin off the back of the hydro, but we're going to attach this part as a prefix to this last word here. Okay? And that's not the end of it, because we're also going to drop and replace the IDE on the end and replace it with IC. And then we have to put the word acid at the end to say that. We have to say it's an acid. This would be hydroiodic acid. Hydroiodic acid. Okay? Okay, let's put together an acid. I'm going to let you do the whole thing, and I'll check behind you, okay? We're going to build an acid using a sulfur ion. Okay? The sulfur has to be a negative ion. Okay? So I want you to write a formula for an acid that has this negatively charged sulfur ion, and then name it.
How do we go about that?
Well, use the periodic table with oxidation numbers to find the negative charge. Okay? Where do you find the charge on a hydrogen ion? There you go, right in there somewhere. Sure. If the sulfur is negative, what charge does the hydrogen have to have? There you go. Just a puzzle. Got to put it together.
I got it now.
Okay. All right. So sulfur has a negative charge. Hydrogen's got to have that positive charge. Do I need to do the math down here, or can we figure this out without it? Okay. There's the formula. Okay. Now we're not going to call it dihydrogen because we're naming it like an ionic compound.
That's only organic compounds, right?
That's only covalent compounds.
Yeah, covalent.
Okay. At least that kind of prefix. All right. So we're going to name this what? Like an ionic compound. Hydrogen sulfide. All right. Now we got to go through that changing things around thing. We're going to get rid of the gin, put it together with that name. We're going to put an ick on the end here. We could call it hydrosulfic acid, but that sounds better if we say hydrosulfuric. Wouldn't you think that?
Yeah.
Okay. Well, we're going to do that anyway. All right. The UR gets put back on the phosphorus and the sulfur names because it sounds better. Okay. So we call it hydrosulfuric acid. Hmm?
See, I named it that way and I wasn't even thinking.
There you go. Because it sounds right. Yeah. Sounds right.
Actually, I didn't think it.
Don't break the glass over there now. That's all right. Just don't break the glass. What?
Will everything be like that where you just take the element and add X? Or
No, not everything. This is only for binary acids. Binary acids. Do we need another practice here?
No, sir.
No? We're okay?
yeah,
Everybody's cool with that?
yeah.
All right. Then we can go to... Well, I'll tell you what. I did tell you that we were going to include cyanide in our binary acid naming system, right? Let's do one with cyanide. Yeah. Let's do one with cyanide. Everybody do an acid that has a cyanide ion.
What do you mean?
Cyanide.
What do you mean do an acid with a cyanide?
Write the formula and name. Write the formula and name.
We're talking about
All right. Cyanide is a negative ion. We're going to treat it like it's a binary acid, even though it's ternary. It's got 3 elements because this is an anion that doesn't have any oxygen in it. Okay? So we'll put Cn negative with hydrogens to get a balanced formula. How many of each do we need? One of each. So we get HCN. Name it like an ionic compound. What are we going to call it? Hydrogen cyanide. Okay. Change that name to an acid. Hydrocyanic acid. Okay.
Do we have hydrogen cyanide, or can we just go ahead and put hydrogen?
Let's see. This is kind of a tricky question because it requires you to be mature enough to know whether you can do it without this in-between step. Okay? Unless I ask you for it, I'm probably not going to check your in-between step. Okay? If the question says, give me the name of this compound if it's not in a solution, then you have to say hydrogen cyanide. Okay? But if I say name this like an acid or name it, period, you could say hydrocyanic acid. Okay? Yes?
Is hydrocyanic, is that one word or two?
Hydrocyanic is one word.
What about hydroiodide?
It's all, see, it's joining together. That's what I did up here. I showed them joining together. So this is all one word. This is all one word here. Okay? Alrighty then. Let's do oxyacids now. Oxyacids. Now, oxyacids are just acids that have a polyatomic ion that contains oxygen. Any acid, and acids have to have hydrogen on the front, at least in the physical acids, non-organic acids. They have to have hydrogen on the front in the formula. But the back then is going to be one of those polyatomic ions that contains oxygen. So we can go to the list of common ions and find any oxy-ion, anion we want. Any one of them. And we got bunches and bunches. Okay?
Permanganate.
What? Perm what?
Permanganate.
Permanganate. Okay. All right. Permanganate. Okay. Okay. Permanganate. Okay. I don't know of an acid that's formed from that, but we can do it anyway. That's fine. Just for this exercise, we can write the acid. All right? We need what on the front of this?
Hydrogen.
Actually, hydrogen ions. Okay. How many of each do I need? Okay. So let's name this like an ionic compound. Again, we're going, as long as it's non-organic acid, we're going to name it like an ionic compound first. So what are we going to call this? Permanganate. Yep. Hydrogen permanganate. Hydrogen permanganate. Now, with the binary acids, we changed hydrogen to just hydro. Okay? That's right. We're not going to do that for the oxyacids. For the oxyacids, we're going to get rid of the hydrogen entirely. All right? We're going to change any 8 endings to ic endings. And anytime we have an ite ending or suffix, we're going to change that to an us suffix or ending. Okay? So permanganate becomes permanganate, yeah. Permanganate, and we use the word acid on the end. You know? It's probably possible to make this, but I've just never heard of it being used for anything. Just thinking about it. Okay? Everybody got that? All right? Somebody else want to pick another oxyanion? Let's make another acid?
No.
No, you don't want to pick one? Let's not go quite that, but that, remember, even though that has an 8 on the end, there's no oxygen in that one. He was chewing. Yeah, but there's no oxygen in that one, so we're not going to use that one, okay? Oxalate's good.
Thiosulfate.
Well, let's do oxalate. You already said oxalate.
I like oxalate.
Okay, oxalate. All right, using oxalate, the anion, build a formula, write a formula for the acid, and write the name for it. And this one does actually exist. Okay, we got oxalate, which is C2O4 with a 2 negative charge. Okay, what are we going to put on the front of it to make it an acid?
Hydrogen.
Hydrogen ions. They have to have a plus charge. How many of those do we need? 2 of them. Put them together, we get H2C2O4. Okay, there's the formula. Let's name it. We first name it like it's an ionic compound. Hydrogen oxalate. Now we're going to change it to an acid name, and when we have an anion that has oxygen in it, an oxyanion, we're going to drop the hydrogen name off the front. It's gone. Okay? We're going to change 8 to ic. And we have to put the word acid on the end here. Oxalic acid. It's just new. It's not really hard. It's just kind of a new thing. Okay? You got that?
Just if you need my approval.
I do need your approval, yeah. Now, the question that Luke was asking me was about the formula underneath it on the common ions list here. Okay, this is an organic way of writing this formula. Okay, which we'll get to later. If we were writing that like an organic formula, we'd write it Who could?